This video is going to explain how to calculate slope. There are two different ways of calculating slope, and we will learn about both of those in this video. I would suggest that you take notes while watching this video. Pause it if you need to. Go back and replay portions of it if you need to. And at the end there will be some questions that you need to copy down into your notes and bring to class with you next time. Before we get into actually calculating slope, let's first talk about what is a line. A line contains infinitely many points that extends in two opposite directions without end. So it's a bunch of points. Imagine them connected to each other and just going on and on and on forever and ever and ever. It's a continuous function, and we'll talk more about what a continuous function is throughout the remainder of this year. There are two ways of calculating slope, and we will discuss both of these ways of calculating slope in this video. Rise over run works best when you are given points on a coordinate grid, and the slope formula works best when you are just given two coordinates and no grid to look at. The first method is called rise over run. As you can see on the arrows on the left side of the graph, rise is up and down and run is left and right. So what you do is you choose any of your points to start with. For example, let's say that I choose this point down here. And I'm first going to count the up-down direction to get to my second point, which is over here. So I'm going to go up 1, 2, 3, 4, 5 spots. And then run is left to right. So to get over to that point, I'm going to go to the right 1, 2, 3, 4. And that's how I calculate the slope. But let me actually draw in on the graph what has happened. So we said that we went up 5. So when we go up, that's a positive direction. So we went up 5. And then we went to the right 4. And that's positive direction over also. So this is rise over run, just like it sounds. My rise was 5. My run was 4. So the slope of this line is 5/4. And leave it like an improper fraction. Don't worry about moving it into a mixed number. You can just leave it as 5/4. Now, we started with the point furthest to the left. What were to happen if we were to start with the point to the right? So if we were to start with this point up here, would we still get 5/4 as our slope? Let's take a look. So starting at that point, I'm going to go down 2, 3, 4, 5. And since I went down, we can say that's a -5. And to get to that point, I'm going to go to the left 1, 2, 3, 4. Since I'm going to the left, that's a -4. My rise was -5. My run was -4. Negative over negative gives me a positive, so this is still going to be a slope of 5/4. So it doesn't matter which point you start at, as long as you do your rise first, going up and down to the level of the next point, and then go left to right until you get to that point. Here's another example. Again, you can start with either point. Let's just, because it makes more sense, let's go ahead and just start with this first point here, furthest to the left. Just by looking at this graph, what type of slope does this line have? This line has a negative slope. So when we get done with calculating the slope, we should probably have a negative number. Well, it's not we should probably have. We should have a negative number. So from the point furthest to the left, we're going to go down 1, 2, 3, 4. We went down, so that's a -4. And then we're going to go to the right 1, 2, 3, 4, 5, 6, 7, 8. And since that's to the right, that's a +8. So again, we're going to do rise over run. Our rise is -4. Our run is 8. So the slope is -4/8. But with all fractions, we can simplify them to simplest terms. And -4/8 is the same thing as a -1/2. Now if I had done it the other way, starting with the point to the right, I would have had a positive 4 and a negative 8. The slope still would have been negative 1/2. The second way of calculating slope is called the slope formula. And here's the slope formula on your screen. And let me break down this formula for you. M is just the way that we refer to slope. So whenever you see M in a problem when we're dealing with linear equations, it's just slope. That's just what we call slope. y2, y1, x2, x1 both refer to the 2 points that we're looking at. One of our points is going to be x sub 1, comma y sub 1. That's one of our points. The other point is x sub 2, comma y sub 2. Those are our 2 points. Those subscripts 1 and 2 are just letting us know which points we're dealing with. And as we're doing this slope formula, what's important is that whatever our first point is, they should fall right on top of each other in the slope formula. And whatever our second point is, same thing, it should fall right on top of each other. Don't mix up the x1 and the y2 or the x2 and the y1. Make sure you stay consistent based on the formula. So we want to find the slope of the line that passes through the points negative 2, 4, and 1, 6. So first thing we need to do is determine which is our first point, which is our second point. We'll see in a moment that it doesn't matter which one we pick. We should get the same answer either way. So let's, because of the way the problem is set up, let's say that the first point is x1, y1, and let's say that the second point is x2, y2. And I'm just going to substitute that information into my formula. y2, we said, is 6. y1 is 4, so that's 6 minus 4. All of that is over. x2 is 1. x1 is negative 2, so that's minus a negative 2. But from our work with integers, we know that subtracting a negative is the same thing as adding. So I have 6 minus 4, which is a 2, and I have 1 plus 2, or 1 minus a negative 2, which is a 3. So the slope of the line that contains the points negative 2, 4, and 1, 6 is 2/3. The slope of that line is 2/3. And just so that you can see that it doesn't matter which point is first and which point is second, in red I'm going to go ahead and do the same thing using the points in the opposite direction. So y2 in this case is going to be, y2 in this case is going to be 4. y1 is 6, so 4 minus 6. x2 is negative 2. x1 is 1, so that's negative 2 minus 1. 4 minus 6 is a negative 2. 2 minus 1 is a negative 3. Negative 2/3 is still going to give me a positive 2/3. So my slope is the same no matter which point I use as the first point and the second point. Here's another example. We're going to find the slope of the line that passes through the points 1, 2, and 5, negative 6. Again, it doesn't matter which one is x1, y1, and which one is x2, y2. So let's just go ahead and keep it in the order that's there. So y2 is negative 6. y1 is 2, so negative 6 minus 2. All of that is over x2 is 5, and x1 is 4, so 5 minus 1. Negative 6 minus 2 is negative 8. 5 minus 1 is 4. And when I simplify this down, negative 8 over 4 is really negative 2. So the slope of the line that passes through the points 1, 2, and 5, negative 6 is negative 2. Here's your quick check. Copy and answer these questions in your notes. Describe the 4 types of slope. And what is the slope of the line that passes through the points -6, 4 and 4, -2? So copy these 2 problems down and answer them in your notes. Bring them with you to class when they're due.